question 14. Ignacio and Oliver playing another game with the algebra tiles. Boy, they like their games with the algebra tiles, don't they? After they simplify two new expressions, they are left with the expression on their mats as shown at the right. They could not tell which part of the mat is greater by looking. So here they simplified, and this is what they came up with, and they're not sure which side is bigger because they don't know what x is. All right. Hold on, I want to get rid of some of the stuff I have on the screen. Way too much stuff going on. All right. So now, one way to compare the mats is to separate the X tiles and the unit tiles on different sides of the mat. So notice we have an X tile, and this is what they're calling the unit tiles. They want to get them on different sides of the mat, all right? And that would help us make a better idea of which side is larger. When they're mixed up, it's hard to tell. So they want to find out a way, so work with your team to find a way so only X tiles are on mat A. So we want to have only X tiles here. Make sure that you're able to justify. All right, so somehow we have to get rid of these right here, all right, these negative ones. So I'm going to set this up like we did on the other one. So I want to get this X all by itself is what A is saying. I want to get rid of these tiles somehow. So I'm going to set this up, make sure I got, 6 of them. All right, so I'm going to go back to this so I can pull up my tool. And they have an X, and then they had 6 of these. 3, 4, 5, 6, except they were negative. All right, so question A wants to know, I want to get this X all by itself. I need to get rid of these somehow. So what can I do to get rid of these? I want these to go away somehow. So I guess here would be my thought. If I were to add a 1 to this, these would cancel out because of 0 pairs. So remember how we can take off the same thing on both sides? Then I think that we could probably put on the same thing on both sides. So if I put a positive 1 on this side, I also have to put a positive 1 on this side, all right? Because this is just the opposite of what we've been doing. Instead of taking the same number off of both sides, let's put the same number on both sides, and that keeps it equal. So that would give me a 0 pair, so those would go away, but I still got more to get rid of. So I'm going to do this. I'm going to add another 1 to this side, and that means I got to add another 1 to this side. Notice whatever I do to one, I do the same thing the other. I added 2 positives, so I added 2 positives. I want to add another 1. That gives me another 0 pair, so then I got to add another 1 over here. So now I've added 3 to both sides. Do it again. So notice now I've added 4 to both sides. Now I've added 5 to both sides, and now I've added, 6 to both sides. So what I did is I did the opposite of what we've been doing. Instead of taking things off of both sides, I put the same thing on both sides. And the reason is because these now give me 0 pairs. And I can just take them right off the board because they cancel each other out. So I'm taking off all of these 0 pairs. So now I have X all by itself over here, and that's what they wanted me to do. Let's see what the question asks. So let's see. One way to compare is to get X by itself, so we did that. Part B, so we did that. So if I go back to this, here's this idea that which side is larger? Well, it depends once again. So this is worth 6, this is worth X. So depending on what I put in for X makes a difference on which side is bigger. If I say that X is equal to 2, well, then this side's bigger. If I decide I want to make X worth 9, so this is worth 9 now this side's bigger. But the whole goal of this question was figuring out how to get the unit blocks, get these X all by itself. And I did that by adding the same thing to both sides. All right. So now the question comes up. Let's see what we got here. Use the same reason from part A. How would you have only variable on mat B? So now I'm going to use this right here, but I want to have only this variable on B. Notice how we have a bunch of stuff over here on B. I want to have just X on B. So the first thing I'm going to do is I'm going to set it up here in just a second once I write it down. I got X, and then I got 1, 2, 3, 4, 5, 6, and I got 8 positives. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Yep, 8 positives, and I have 2 negatives. All right, so I'm going to set this up on my board again. So I'm going to go back to this, just so I have a tool. And on the left-hand side, I have 4 positive 1s. And over on the right-hand side, I have an X. I have 8 positive 1s. 1, 2, 3, 4, 5, 6, 7, 8. And I have 2 negative 1s. All right, so this is now, oh, whoops. I need some more stuff here, don't I? Wait a second. No, sorry. So it's this board right here. All right, so I just reproduced this board over here so I can move some stuff around. So now the question is, I want to have only the variable on mat B. So I want to get this X all by itself. So let's see, what could I do? The first thing I think I would do is I'm going to see if I can simplify either side. So I could do this. I could do some 0 pairs on the right. So these give me 0. So they're gone. I could do another set of 0 pairs. They're gone. And let's see, can I do some more simplifying? Oh, I can take the same thing off of both sides. So I've got a positive 1 here and a positive 1 on this side. So I can take them off the board. I've got a positive 1 and a positive 1. So as long as I'm taking the same thing off the different sides, I'm good. I can also take 1 off of here and 1 off of here. So I'm taking the same thing off of both sides. And then same thing off of both sides. So the first thing that I'm doing is I'm simplifying as much as I possibly can. But remember, I want to get this by itself. These are still here. And I need to get rid of them somehow. So I'm going to do what I did in the last problem. And I'm going to do this. I'm going to add a negative 1 to this side and a negative 1 to this side. Because remember, as long as I do the same thing, we're good. And the reason I'm doing this, because then these will cancel each other out. All right, there's my 0 pair, so I can take it off. All right, I still got this, though. I want to get rid of it. So I'm going to add a negative 1 to this side. But if I do that, I got to put another 1 over on this side. So now we have our 0 pairs. They can go away. So notice I got my letter all by itself. And the way I did it, I simplified as much as I possibly can from our 2 legal moves. And then I added things to both sides to create some 0 pairs. And so now I know this. In this problem, whatever, I have X all by itself over here, and over here I have a negative 2. So depending on what I put in for X, makes a decision on which side is bigger. All right. So if I make X a 5, so if I just make a decision, I say, you know what? I want X to be worth 5. This side's bigger. If I decide I want X to be, why won't these go away? So let's do this. We'll scribble it out. How's that? If I decide that X is a 0, well, this side's bigger. If I decide that X is a 5, this side's bigger. If I decide that X is a negative 5, though, all of a sudden now this side is my bigger side. So the main thing we learned in this question is how to get things, we simplified, and then how I could get this letter, how I got this X all by itself.